Today, we are tackling one of the greatest engineering marvels ever built, the Panama Canal. And the whole thing kicks off with a number that's just, well, it's pretty wild. 87 feet. Okay, that's almost 27 meters. Just try to picture that. Maybe like a 9-story building. Keep that number in your head for a sec, because that is how high the Panama Canal has to lift ships. We're talking over 1 million tons of them every single day. It's just an absolutely bonkers feat of engineering, lifting all that weight up and over an entire continent. So that's the big puzzle, right? How in the world do you lift 100,000-ton ship? Something that massive, almost 100 feet straight up. I mean, you can't just hook it up to a crane. So what's the secret? Well, the answer is this beautiful mix of being super simple and unbelievably clever. Okay, so let's get into it. The whole reason you need this 87-foot lift is because a huge chunk of the canal is actually a massive man-made lake, Gatun Lake. And here's the kicker, it sits way higher than the oceans. You can't just cut a channel to it because the whole lake would just empty out into the sea. So the engineers had a choice: dig down through miles and miles of rock, or figure out how to make ships climb a mountain of water. And their solution, the lock. You can basically think of it as a giant concrete water elevator. It's a huge watertight chamber with a gate on each end. This simple idea, this box, is the key to the whole operation. But even the gates themselves are a work of genius. You know, if you just put a flat gate up, the sheer pressure of all that water would just bend it and break it. No way. So instead, they use these angled gates called miter gates. And get this, the water pressure actually pushes them tighter together, sealing them shut. They literally used the force that was trying to destroy the gate to make it stronger. How clever is that? All right, so you can't just swing open the main gates to fill the lock, right? The rush of water would be chaos, it would be like a tidal wave. So instead, they use something called sluices. They're basically small, manageable channels built into the lock walls. Think of them like the drain in your bathtub, but in reverse. They let water flow in and out in a controlled, predictable way. And the best part? The whole system is powered by one thing: gravity. It all comes down to a super simple physics principle. Basically, if you have two connected bodies of water, the water will always flow from the higher one to the lower one until they're both at the same level. That's it. No giant, energy-guzzling pumps needed. You just open the sluice, and gravity does all the work for you, for free. So let's walk through it. Imagine you're on a ship. You sail into the lock from the low side. The huge gate closes behind you. Then, whoosh, the sluices open and water from the higher level starts pouring in. You're not moving, but the water around you is rising, and it's gently lifting your entire massive ship up, up, up. Once the water inside the lock is level with the water ahead of you, the front gate swings open, and you just sail on out. It's an elevator, just a very, very wet one. Okay, so that's how one lock works. But remember that 87-foot number? That is way too high for just one lock. The pressure would be insane. So how do they handle it? Well, they didn't build one giant elevator, they built a staircase. That's right, instead of one massive 87-foot lift, they built a series of 3 locks on each side of the continent. A ship goes into the first one, gets lifted about 30 feet, sails into the next one, gets lifted another 30 feet, and then again for the third. It literally climbs up this giant staircase made of water, one step at a time, until it reaches Gatun Lake. Now, this whole system is just brilliant, but there was a huge hidden catch, a problem that wasn't totally obvious at first. See, using all that free gravity to lift ships, it comes with a price. Here's the deal. Every single time a ship goes through the locks, a gigantic amount of fresh water, millions of gallons, flows from Gatun Lake downhill and gets dumped into the ocean. It's just gone. And Gatun Lake is only filled by rain. So, what happens in a drought? If the lake level drops too much, the entire canal could literally shut down. It's a massive vulnerability. Now, the staircase design is actually pretty smart about this. When a ship goes down the staircase, the water from the top lock is used to fill the middle lock, and the water from the middle one fills the bottom one. So there's some reuse happening already. But with more and bigger ships and a changing climate, that just wasn't going to be enough to solve the problem. Which brings us to the modern day canal, and what is arguably the most brilliant part of the whole design. A fix so smart it's like they're recycling a small piece of the ocean with every ship that passes through. What did they do? Well, right next to each of the new, bigger locks, they built 3 gigantic concrete tubs. Seriously, they're enormous. And their one and only job is to act like reservoirs to hold and save water from being wasted. Okay, check this out. It's so cool. When a ship is going down and the lock needs to be emptied, they don't just dump all the water. Instead, they drain the top third of the water into the first basin. Then the next third goes into the second basin, and the third bit into the third basin. Only the very bottom part of the water is actually lost to the sea. And then, to lift the next ship up, they just reverse the process. They let the water flow back in from the basins first, which fills up most of the lock. They only need to take a little bit of fresh water from the lake to top it off. And the result? It's incredible. This system saves 60% of the water for every single ship. 60%! That is a game changer. It makes the whole canal so much more sustainable and resilient, especially when you're worried about droughts. So, in the end, you have these 2 amazing ideas working together. First, the staircase, which solves the height problem by breaking it into small, easy steps. And second, these water-saving basins, which solve the water problem by recycling a huge chunk of it. It's this combination that makes the whole thing work so beautifully. It's just such a powerful example of human ingenuity, isn't it? A system that uses simple gravity to do the impossible, and then gets even smarter to make sure it can keep doing it for another 100 years. It really makes you think. The canal solved a huge problem for the 20th century. What are the engineering marvels we're going to need to solve the problems of our century?